So we are starting our second part of the program now, and I just want to announce certain things. First of all, we follow the same format as earlier. We're going to have some presentations first, and then we'll have a panel with the opportunity to comment on each other. And then it will be open for the public, for you, to come up with questions and comments. The second announcement is that, unfortunately, Rebecca Bosch, from the State Secretary for the Ministry of Education and Research, was announced earlier. She couldn't come because she felt sick. That gives us the opportunity to end earlier. Now, unless we have to really be frustratingly dominating you guys, we will end earlier then, right? Unless there are, really urgent issues. And the other thing I want to say is that we will keep that session in English, except if you want to have some interventions in Norwegian, you're open for that. But we can, I think all the presentations are in English, but if you want to speak in Norwegian, that will be okay, right? So it will be a little bit of a mix. And finally, I want to say, what was the final point I wanted to say, which I forgot now? Well, anyway, the topic is now, how does that translate to what we have in Norway, and what can we learn? So, and with this, I invite Øystein Hov from the Norwegian Academy of Science and Letters to talk on this.
Thank you very much. My background is as a meteorologist, atmospheric chemist, environmental scientist, and I will speak about two things. It's some of my own experiences in the science advice in environmental sciences, and then I will say a little bit about how we try to approach the science advice work in the Norwegian Academy of Science and Letters, which to some extent builds on the experience that we have from, for instance, the environmental sciences science advice work. I start with this. I think the executive summary of the report is very pragmatic and useful and provides some rather interesting information. And this sentence here, these sentences I like quite a bit. Scientific expertise supports effective policy making by providing the best available knowledge, which can be used to understand a specific problem, generate and evaluate policy options, and provide meaning to the discussion around critical topics within society. And so scientific knowledge is crucial, and scientific knowledge is instrumental in understanding phenomena. I think this is a good analysis and a pragmatic description of how to proceed. I will speak from my experience in environmental sciences, as I said, and I would mainly speak about the role of the scientist in this work. And I try to draw on a figure. The issues I will give some examples from, or some of the issues, not all of them, is acid rain, air pollution, ozone layer depletion, climate change, Earth system behavior in the Anthropocene. These are issues which have large societal implications. And around these issues, one may say that the science community circles, the policymakers, there is a pool sometimes, a public, political, economical pool, and there may be a pool of evidence and knowledge. And that can be an instant picture, but there can also be a third dimension in this, going from something that there could be a public outcry. We really have to do something, or it could go all the way to the horizon scanning, the foresight mode of this. This can correspond to a time scale, which so that this picture moves with time, and the constellations between these boxes change with time. The behavior of the science community in science advice can be seen as this. This is a traditional relationship with the scientist on one side of the wall throwing over his information, more or less relevant, to the policymaker on the other. And there are also walls inside the science community, of course, because everybody likes to sit in their own box. and that's where they are most productive. In my opinion, this picture, this model, is not the best one for science advice. We have the other one, this figure here, drawn by Ole Seierstad here in the audience, which is the translational science demonstration, which is more a value cycle, which goes from the discovery continuously over to translation, over to application, and where and it's all curiosity driven, and this can, and you have a reinforcement here through that the application side feeds back into the discovery and translation side, etc. And if you break this circle, you also break this strong mechanism where one component reinforces the other. And in my view, this model here is, in my experience, much more fruitful than the first model. So this is, in a way, these two are on the system level. And then we have the third one, which is on the individual level. I think the honest broker role is the important one in this hierarchy, the one that engages actively over time with policymakers and societal sectors to solve particular problems by developing policy alternatives. And this work is a continuous one as the policy actions and the other boundary conditions change and modify. I will now give some examples from a few of these areas. Some of them are rather complicated. And I start with the acid rain. You all remember acid rain. That was when the environmental movement was born. We got the Minister of Environment, and we got the sort of organized interest in environmental issues. 1972 Stockholm Conference. In 1969, Svante Odén in Sweden sounded the warning clock. So that was the pull, start of the pull on the acidification issue. That moved very quickly into a research interest and a policy interest. And of course, these two had to join forces in order to get some action going. And we very soon started to develop something which I now think was the honest broker role on the top there, which evolved over time, creating a dynamic and trusted relationship between the science community and the policy processes with both formal, exploratory, and reviewing mechanisms, as well as experts acting in individual capacity. That evolved, I think, during that policy process. Other aspects that came up, which were very important, was to create bridging concepts that was useful both in science and in applications. And some of these were, for instance, critical load, and that is how much a natural ecosystem actually can endure of acid deposition before it changes or get damaged. Blame matrix is in a way what one polluter caused of impact somewhere else. A matrix of blames, source receptor relationship is related. All these bridging concepts were then continuously quantified in an operation sense by research and handed over to and used in the policy making. And just some illustrations from workshops below. In mathematical terms, this was formulated as how impacts, what the cost of the damage was and what the cost of the damage was to reduce the impacts. That's the left differential. It's a product of three things. It's how the impact depends on the air quality, which was the deposition amount, and the air quality depend on the emissions, and the emissions, they depend on costs. If you reduce them, it has some costs. So that's the three terms we quantified in acid rain, and these called on 4 different communities. The impact one to the left, that is the policymaker and the economist. And then the impact on air quality, that is the effect people. So that is the ecosystem people. The middle one, air quality emissions, that is the atmospheric scientist. And the emissions over costs, that is the technologist looking at the processes that emit. So then immediately you coupled four different communities. And that was not only done in science, but also in terms of the organization with the organizational structures on above, with working groups on all these 3 or 4 topics: strategies, effects, the science, and the emissions, ruled by an international executive body under the United Nations Economic Commission for Europe. So we then got scientists in different disciplines floating between these different areas, and the policymakers as well, over time. So you got this trusted relationship, which was also formalized. That worked very well, but it's of course a very large enterprise. So in acid rain policy process, some scientists continuously worked also in the translation and application parts of the value cycle in the honest broker role. And the measure of success is demonstrated here. In Europe, it's the science development in the left panel, it's the policy development to the right, and from 1970 to 2010. So it's a very substantial list of international agreements that has contributed very significantly to both to the ecosystem improvement, to water quality, and of course to air quality itself. And we're now, in a way, pushing towards what is this system worth today? Because the organizational structure is still the same, the science community is still there to some extent and mobilizable, but the pool is not as strong anymore. And the horizon scanning component is then not sufficiently active, because this system here is actually able to analyze a large number of pressing issues like water quality, the link between air quality and climate, the biodiversity issue, for instance, but it's not running at 100% capacity nowadays. The next one is ozone depletion. That is also a success story. In the mid-80s, we found that if the emissions of chlorofluorocarbons continued as they did then, the UVB levels would be intolerable in 2 or 3 decades. So then the same system, which was not very unlike the acid rain system, was established, and we got the Montreal Protocol under the Vienna Convention already in 1989 with later amendments. And the right-hand side is the measurement of the success with the ozone being now in recovery, and has been that for quite a while. A third example, which is quite different, we had the Eat Lancet Commission recently, Food in the Anthropocene, on healthy diets from sustainable food systems. The Academy was to some extent involved there and had a meeting on it. The message from that commission was very quickly brought into a political public discussion, which tore it apart completely because the assumptions were not understood, in my opinion. Because the assumptions were highly important. Do boundaries for the Earth system's biophysical subsystems exist within which there is a safe dietary operating space for humanity as judged by 6 processes: climate change, the reactive nitrogen cycle, the phosphorus cycle, the water cycle, biological diversity, and land use change. Given sustainable requirements for these 6 processes, the EAT Commission derived a diet space sufficient to feed a global population of 10 billion people without large risks of hunger or overweight deaths. And that is a very important issue, in my opinion, also for climate change and other, and for all these 6 points. But there was no science advice mechanism established. So it very quickly became a matter of having more or less sheep in Norwegian rural areas. But this was not about Norway, it was global. I think I will say that the EAT Commission was not successful really yet because the science advice process has not started. It was not established. So this picture here didn't work, but it needs to work because this is a very important issue. Not, of course, not specifically for Norway, for the globe. And this cycle at the bottom was not operating. One may say that the one component of this, which is the reactive nitrogen issue, does not work either, because it's so strongly dominated by agricultural policies, which have quite different purposes than making the reactive nitrogen cycle sustainable. And this is just to show that the anthropogenic control of the global nitrogen cycle is dominating the natural cycle. So here either there is not a science advice mechanism functioning, agricultural complex is dominating. I will not say much about climate, but I will say that my conclusion is that it's too much like the left figure and too little of the right figure in the climate discussion, and has been so since the advent of IPCC. It has improved a bit, but I think it's far too much like the left part of the graph. And that is, in my opinion, part of the reason why it has really got stuck for so long. Of course, also because it's a global issue dominating so many sectors, but it has been given a far too slow start and is stuck. And I think this is part of the reason. So what is the science advice approach in the academy? Well, we looked at this figure here. We take the ESAC and SAPEA reports as our issue definers. And they have been forestry, soil use, climate and health, sustainable transport. And then we link a relevant science community up to those issues. They can come from expert centers, excellence centers in Norway, because we want to bring this into a Norwegian context and translate them into Norwegian context. And the policymakers are mainly ministries. So the evidence is from ESAC and SAPEA. So that is our starting point. And then we try to get this loop running over time. And we do that by using these issues as they originate from SAPEA and ESAC. We engage the discovery, the research units, relevant ones. The academy is the facilitator, the translator between the science community and the application community. And the application is the policymakers and ministries. And then the trick is to get this loop going, not just in our meeting, but allow it to evolve. And then the translation mechanism here is not the driving one. It is the relationship between discovery and application. That is the mechanism that has to run with time in order to make this loop successful. And the academy can only be a facilitator at times, because that is our role in society. So that is how we try to do this. Summing up here, that is the science advice by the Norwegian Academy of Science and Letters. And we need to collaborate with the other science academies, in particular NTVA, to make this running. And now I only one slide left, and that is outlook. I think that Earth system science evolution and results can have significant societal implications. That is obvious. And I think that national science advice should work in a systematic manner before there is a public outcry or strong political pressure. And I think that the samarbeid, arbeidsdeling og det var konsentrasjon should be reintroduced, because organizations need to change here in order to attack these issues properly. And you have environment-related topics like weather, air quality, deposition, climate with adaptation, mitigation, geoengineering, not least, biodiversity, water, food, area use, urban development, energy, transport, industry, agriculture, marine sectors. But I also think that other sectors than the environmental sector are as applicable or in need of such science advice approaches, like how we do health services, how we do educational services, and how we do research in general. All those need also to be looked at in this perspective, which is not really the case. Okay, you look at me, so I think I should stop there.
Yeah, thank you very much, Øystein. You can also maybe sit down here. And it was very good to have some very specific examples. We're going to hear the next speaker is Kyrre Lekve from Simula. But I understand you also have some previous experience from the policy side. So maybe we can hear both aspects. Please, the floor is yours.
Spoilers. Spoilers. Good afternoon. I would start with two assumptions. The first one is that the stories we've heard so far, they are a little bit linear. It's the description about the politicians asking the experts about their opinion, getting some nice opinion back, and then try to find out if they should listen or not and make a political decision. That linear model is only part of the truth. So my first assumption is that most of decisions today are messy. There are interactions, there are some scientists, some science advice, and a lot of other interests going into the decision-making process. So that's my first assumption. And the other is, related to the first one, is that there's always someone that would like to influence decisions. And if that's not science, then there's something else. I prefer science to influence more than a lot of the other things. So that's basically my two assumptions and what I'd like to describe a little bit about how this is actually happening in Norway. Now I work at a research organization, expertise in information and communication technology. But we are no different than other actors within academia. We have knowledge within our field, and we have an obligation, in my view, to contribute with that knowledge into the decision-making process. And that means we're already at the first problem, is that when we communicate our knowledge, we also have some self-interest. Just if the politicians are aware of our themes, would be in our interest. So this is a problem I would shortly return to. So what are the science process in Norway? Well, there's basically two paths. And scientists of Norway are notoriously bad in influencing policy making because they don't understand the difference between these processes. Norwegian scientists have a tendency to be, their timing is bad and their message is bad. A lot of scientists are good, but a lot are not because they misunderstand. And let me try to, the main point is that these two processes are very different. And you need to understand the difference between them in order to influence the decision-making process. So let's start with the bureaucrat path. In Norway, we have an extremely extensive system of opportunities to provide your input in terms of knowledge, in terms of opinions, in terms of everything. We have all these reports, they are published, then the government or the ministries ask for your opinion. So they say within the next 2 months, please write us what you mean. This is the fundament of decisions in Norway. So that means if you believe something, if your science tells you that we need to take care of the ozone layer, if this is not in the bureaucratic path, it will not happen politically. So you need to have this part of the system convinced about the scientific content of what you know. When you operate in this path, you need to be truth-spoken, you need to be scientific, you need to be factual. This path is no place for exaggerations. This is a place for scientific, proper, calm advice. One problem is that when we communicate in this channel or this path, a lot of the science is disguised as science, but it's really self-interest. Exactly. And I think that's a very good contribution in the report. You says there's nothing like objectivity. You need to make clear where you are, what your interests are. Then you can communicate your science. It's much better if you are open, saying that, well, this is good for us, but this is what we know. Makes it more believable. And also my experience, I used to be state secretary or deputy minister myself in the previous red-green government. And my lesson number one is that the Norwegian bureaucracy is excellent. I mean, they know, they read everything. And they know a lot. And in addition, they need to consider things like practical consequences, economic consequences, where this scientific results actually creates problem for another stakeholder interest, much more than as a scientist. We can say, well, this is important. We need to save the earth, so that we need to do this now. And the bureaucrats will say, well, actually, that's not possible. Maybe we can do it in 5 years, but we cannot do it now. They need to take those considerations into mind. So in the bureaucratic path, you need to convince in an ordered fashion scientifically about something. And you need to have that relationship over time, and you need to build trust. I'll return to that shortly. The other path is the political path. It is totally different. You see that person up there? I think most of us, we have a pretty much common opinion about that guy. That opinion is totally irrelevant. It doesn't matter. The point is, any politician, they are humans. That's all you need to know. They are humans. That means, what should we offer to them that they need? The politicians, they need something that is totally different from the bureaucrats, the bureaucrat path. They need to be re-elected. That's the total key about politicians. They want victories, they want results, they want things that you can see and touch. That's the basics. And that's a totally different story. That means you need, first of all, you need your agenda to be safely rooted in the bureaucratic path. And secondly, you need to create win-win situations with the politicians. So you need to reconcile your scientific content, your knowledge, with political opportunities. So that means you need to be for them. You need to offer them something they need, which is a different story. So a lot of the times when Norwegian scientists do something wrong is that they talk to politicians as if they were bureaucrats, and they talk to the bureaucrats as if they were politicians. Don't mix those two. Let me use an example. This is from our organization. A few years ago, Aftenposten did a really good journalistic job. They discovered that there were some signals. And they investigated very thoroughly. I think they did a great job as journalists. So they found what they thought was spying on central institutions in Norway. And this was about catching telephone signals. Very scary, of course, and new field of knowledge. People don't know too much about it. The politicians don't know too much about it. So this is a situation with a lack of knowledge. A problem in that case was that the scientists of Norway and a few other countries, they forgot that they were scientists. They started to act like politicians, and they said, well, this is a big problem. This must be espionage. And it's a very, it could happen. It's very likely that something like this will happen, has happened, and will happen in the future. However, the data did not support that hypothesis. So we actually analyzed the data, and we told the government that employs us that we can't find this proof of espionage. So we kept our head cold and then provided that information to the government. That was a piece of scientific advice that more of the Norwegian academia institutions should do. Offer your information before you are being asked. So to conclude, advice about advice, distinguish between the two paths and prepare accordingly. Don't underestimate politicians. Don't underestimate bureaucrats. They're both very skillful in their own manner. Remember, they are humans. You don't gain anything by trying to scare them or offend them. Try to talk to them. Create win-win situations and stay scientific and rational. Thank you.
Thank you very much. We are now open for discussion, but I understand we have now a microphone in the room. Can I ask you, I have invited the mayor of a community, Fedje community, who can supply another current case where I think you are asking for science advice in the same way. Could you just maybe have a little introduction to this here? This is
okay.
Yes, as Mathias said, I'm the mayor of Fedje. It's a small municipality in the west coast of Norway. We have a U-boat lying about 1,000 meters from our shores. I need a microphone.
My wife never says that, but okay. The point is that we have 65 tons of mercury lying outside. And Kira, I think you probably know about that one. It was known in 2002. They found it with a U-boat in 2003. And afterwards, they went on a discussion what they should do about it. In 2007, the first time they said they should bring it up. And they confirmed it in 2009. And in 2013, they said they shouldn't do anything about it at all. Last year, they said they should cover it up. And this year, we make them regret that a bit. So now it's still unclear what they will do about it. And Mathias has helped out a bit, working on the case. But the problem is they don't do anything at all with it. They don't know how to solve the case. They're using science, but the problem is, what kind of science are they using? We tried to involve the university in Bergen, but it's hard to get them to acknowledge the science that we have. So what kind of science, what kind of questions are they asking? Because that we know is Kystverket, they don't know what question you're supposed to ask. They're not experts on this kind of field. And that's what's keeping the case like it is today. What is the case? What shall you do? And when the governor don't know the questions, how it is supposed to solve it. Yeah.
Yeah, thank you very much, Stian. We can take that up. This is also a matter of a case that maybe, be stuck in the bureaucratic system without bridging over to the others. But I would like to ask Torbjørn Digernes, who should be here, to join us on the panel from the Norwegian Academy of Technological Sciences. And welcome, Torbjørn. Now, it is up to you to comment on the cases that we have heard, comment on each other if you want to, or to take other further questions and comments from the audience. Would any of you like to comment on any of these issues? Yes.
I think the Fedje case is very interesting because is it a science question or is it a political question? I think that's core in the matter. For one thing that points to the political problem is that whatever you do, if you do something, it's extremely expensive. To cover it up or try to raise it will cost a lot of money. And that's always a big, big problem. So if the politicians kind of know the science, but they know the price tag, they will avoid the problem as much as possible. Because they know if they say, well, this is very dangerous, we cannot have this U-boat just outside your island, and then, or your community, and then if they say that, they have to do something. They have to do something. So you will probably meet avoidance. People try to be unclear in their answers because they know the consequences of admitting to the science. So I suspect this is a political dilemma, and it's got something to do with price.
What if the price is the same? What would you say?
No, the cheapest thing is to do nothing.
Yes,
obviously.
okay. Right.
And the alternatives are so expensive. As far as I remember, those alternatives are extremely expensive. And that's always a bummer.
Is there any current damage?
I don't have the details. I'm just speculating about.
There is a lot of knowledge about that which should be introduced in
I think the basis here is you must have a risk analysis on the table of what would happen if these 65 tons are spilled out, and what is the local and regional ecosystem damage now and over a time horizon of the spill. And I suspect that this has been done to some extent, but perhaps it has not been done in a transparent manner so that it has gained credibility, sufficient credibility in the population or in the science community. Because my feeling is that it has not been a question of money, really, to do this, to lift it out. It has been more a question about is that the right approach, and one has to work on this in a I wouldn't say it's scientific, but a responsible manner, technically, to answer the risk question before one starts to say what the solution is.
Okay, I don't want to say too much on that, but my impression is that what you have been complaining about is that there has not been a scientific expertise. It has been done by consultancies so far, and by the agencies. So this would be a possible area where a scientific mechanism could come in, right? That is, I think, what has been asked for. But was there anything else on that particular issue? But you wanted to... Yes.
If I may, I would like to comment a little bit on the science advice mechanism and try to put it into a Norwegian context to see how should we exploit the fact that there is such a mechanism, and what should we copy, what should we build on? I think it's important questions. First of all, I think the mechanism, as it's now have been presented here, and as it has initially was coined by the SAPEA Quality Manual, will establish itself as kind of a gold standard for scientific advice in terms of the key points in trustworthy scientific advice which when we see the populist groups around the world who is actually undermining scientific knowledge in a way that they actually present it in a way that any opinion is as good as any other opinion, alternative truths and what have you. So the independence part, which the academies can supply, is an important part of this, free of conflict of interest, and as far as possible free of bias. And when, as we know, it's not possible to be free of all bias in terms of values, you need to make sure that it's transparent what values you are applying consist of. And also the transparency in terms of what is the knowledge that a policy recommendation builds on. So that's also a public domain information. Rigorous analysis, and not least the interdisciplinarity. There is no scientific or no social challenge or social problem that can be analyzed in the context of one discipline. It is it's completely meaningless to report something like that. So when this exists now, how and I presume SAPEA will continue for another period. At least that's how it looks, based on the feedback from the Commission. They're satisfied with what has been produced. How should we use this in Norway? The scientific basis, the fact reports, they should be the same in whatever country you are. So obviously we can use that factual scientific basis, and we could, in cases where the Norwegian conditions are differing from what we have, what's typical in other countries, we may have our own 6 wise men and women to interpret the science and adopt the policies to Norwegian conditions. That one approach I think we should take. And as the project goes on, the scientific basis becomes wider and wider. More and more topics are analyzed. Then the U-boat case is an example of something which we cannot expect will come through SAPEA. And therefore we should be prepared when conditions like this, when we find those, we may want to start and do our own effort in establishing the best scientific basis to analyze and understand a challenge that we have. So I think it is that's the way we should try to exploit the concept of SAPEA, build on what is being done there, influence the subjects that are being analyzed, and unfortunately, when we have a mechanism like SAPEA where you actually can do this bottom up, it's easier than going to Brussels and persuade the commissioners that this is from a small country like Norway. It's easier for an academy to do this in an academic society. So this is, I think we should build on that and then use the whole mechanism selectively on subjects that are unique to Norway.
Thank you very much. Excuse me, but if I just to sum up what I understood you saying is, yes, we have here in our hand basically what you think will be a gold standard. You also say that we have some efforts here in Norway, but we are not there yet. We can use it in multiple ways. We can use the SAPEA mechanism as such, and we can design mechanisms nationally that would resemble the same kind of functions here. Isn't that what you're basically saying? So that means there is work to do for us. Well, yes. Good.
I have a question. What would be the role of the Research Council of Norway in such a scientific decision-making process? Officially, they are an advisor, scientific advisor to the government, and they have certain mechanisms about trying to bring up the scientific knowledge on a certain theme. I agree that they don't have a full role as a scientific advisor, but that's still their official status. So that's more a question to you about what's the thought about the Research Council of Norway.
We have at least one representative that I see here who is from the Research Council, but probably we wouldn't get an authoritative view. Anybody wants to say that? What should be maybe the role of the Research Council? Or, I don't know.
I obviously don't want to comment on the Norwegian situation, but there is a separation between science for policy and policy for science.
Exactly.
And that for the European Commission has been the fundamental thing.
Yes.
So, for example, I mean, the ERC, and Øystein is a member of the ERC Scientific Council, does not have a role in giving science for policy, because it deals, in a sense, with policy for science. Yes. And the problem is, of course, that if you ask the research councils for give advice, then it will always be perceived that there is a certain interest behind it in terms of directing more research funding into a particular area. And that's why in the domain of the European Commission, these two things have been kept very, very separate. And it's very clear, for example, in the contract with the SAPER, that SAPER is not supposed to give any kind of advice about funding issues for science. This is outside, completely outside the preserve of SAPER. And I think there's something healthy about that separation, but others may well have other opinions.
Øystein?
No, I don't have another opinion. I agree. I think as long as the Research Council is, so to speak, an arm of the government, it's a governmental agency, it's difficult for an organization like that to be seen as completely separate from the policy aspects. So their advice, which probably will in most cases be very good and nice and objective as objective as it could be, still could be perceived as serving some interests. So I think the model the Commission has found looks much better, at least in terms of acceptance in the both in the scientific community and among the public.
Yes, and building trust, yeah, which is an important issue. I think there was, yes, please.
My name is Kari Øystad, and I used to be Director General for Research in the Ministry of Education and Research. And I would just like to say that the two previous comments were very good comments, and the official role that we have given to the Research Council of Norway is to be an advisor in research policy. And that is what we expect them to give advice on. But the policy advice mechanism is something that is under discussion, as you are discussing it here.
Yeah. Thank you very much. Yes, please.
Yes, my name is Cecilie Rolstad Denby, and I'm representing the Norwegian Scientific Committee for Food and Environment. And this committee has existed for about 15 years, and we do risk assessment for the government. And we don't really give science advice as such, but we do the risk assessments. And I think I'm very happy that this session has been organized here today, because I think it's very important. And we, the scientific committee, we have about 100 academics who is contributing to our work. And I'm very concerned to have new recruitment from young people. And I think it's very important that the young people have trust in science. And I think with the fake news that we know now, so we should really take this seriously and focus on this. And also another discussion going on here now is the open science with the access to open data and open access journals. So I think it's important to remember to build trust in science, because we are, I see that with Trump, that was here earlier, it's a bit of, in the politics, it's we are a bit under threat from the community. So we must take this seriously and work together on this to have trust in science for the next generation.
Thank you very much. I don't have any other now, but let me then be a little bit provocative, if I may, okay? One of the points that we heard earlier today, Jaron was talking about this, and what is also in the report is a certain openness to, let's say, a possible diversity of knowledge. Some knowledge claims that may be false claims, but also some different types of knowledge, for example, indigenous knowledges or other professional, practical knowledge systems. Now, and if we take that seriously, where are we there? I'm thinking we had in our center a discussion just last week, or when it was with a representative from the Sami community about reindeer herding, and the complaint was that a lot of their practical knowledge never reached out to the ministry, basically, that was treating them as any other agricultural system, and that their, let's say, knowledge claims, indigenous knowledge claims, were not given the certain respective status. Now, when we talk about the science advice in Norway, have we taken that? Are we taking this into account? Have we done so? Or is there more to do? How do we view that? I don't know. I'm asking you. Who would like to answer?
Okay, I think there are two possible mistakes to make.
Okay.
The first is by ignoring this kind of knowledge, and the other is by taking it as granted without actually investigating, because we know, for example, that their traditional way of herding, regulating the size of the what is called the herd, was a problem, because the herds were getting too big and it was not sustainable, because their traditional knowledge did not transform successfully into a normal modern society setting. So we missed something in the translation. But I'm very skeptical to not expose native or traditional knowledge to the same principles as we do for the rest of the science. So I think we need to bring it up, but use the same tools to investigate if it's traditional knowledge or whatever it is. But I also like to say we also have, sometimes we threat ourselves as scientists, because we are not addressing our own problems clearly enough. For example, the reproducibility problem that has been demonstrated now, that there's a lot of research that cannot be reproduced. Big problem that we should share more openly. And also one thing I'm very skeptical to is sometimes we abuse our own scientific knowledge. People, they go out with claims in the public sector, signing with the professor, and they have absolutely no knowledge about what they are talking about, because that's something they are not a professor in. So that's also a trust, that's also threatening public trust when scientists are abusing their titles. So we also need to demonstrate the challenges and also the limitations of science.
Yes.
I think the Muscles report addresses this problem with the potential schisma between the elitist scientist and the practitioner, who also owns his own experience and has knowledge that is relevant to a policy question. We should never forget that, and we need to try to reconcile this in a way that we treat them in the arenas where they belong. If it is not science-based, we shouldn't contrast the two. Then it has to do with practice, it has to do with values, it has to do with culture. That is also important aspects, and that's why the scientists should not make the policies. They need to be adopted and to the cultures where they are going to be applied.
Yes, we have the audience here.
I'm not sure if this is a kind of a wrap-up question that you may have for yourself.
Well, no, we can have many more questions, so it's
all right.
Just go ahead, please go
no,
on.
I was just thinking about this balance between science and policy that is involved in SAPEA and perhaps what we're going to do in Norway. And I would like maybe to ask Ole Pettersen, who's been involved in this for a long time, to share some thoughts with us on how you hit the balance between coming up with science for policy that the politicians would be interested in, and that we as scientists perhaps could also want to talk about topics that they would not be interested in. So it addresses a little bit to the question at the beginning of this session. So if you have any thoughts on that, because although I agree the Research Council should definitely not, I think, be part of the funding for any science advice institution in Norway, but still some funding is needed. So you need some kind of goodwill somewhere.
Yes.
Thank you. We do have, I mean, the option, of course, in spite of not being asked to give advice in terms of funding, it can be a result of an evidence review report that we highlight areas where the knowledge is particularly missing. And that certainly is allowed. So we will not give specific advice about who should be given money or anything like that. But clearly, if there are very dark areas that actually seem to be quite important, it is perfectly reasonable in an evidence review report to draw attention to that. And there's nothing wrong with that. Then it is up to the 7 wise men to see whether they think that there should be a specific advice about that. So that certainly is possible. Unfortunately, I and several others have to leave now in a moment, so I just want to take this opportunity also to thank you for what I think has been a very interesting discussion. And I would finally agree with you that the scientists also, of course, have a very big job in keeping their own house in order. And that should not be forgotten. And sometimes there is exaggerated claims about fraud, and sometimes there are, on the other hand, people who dismiss that it's not a problem at all, and the truth has always probably lies somewhere in between. But we must be very open about this, and the open science and the open access, I think, is actually an important part. And in fact, the reason we are leaving now is that we have a big Plan S meeting in Leuven over the next days, actually, to discuss how to progress that agenda anymore. So anyway, from my side, many thanks to all of you for a very good discussion.
Thank you.
And apologies for having to leave.
Joining us. I would like to keep you for a little bit longer, also to give you the opportunity to come up with any further questions. One of the things that I heard now, and that you just stressed, is we need to have a little bit more reflexivity also among us as scientists here in the community. And one of the things that I learned from Silvio Funtovic very early was he had this nice thing. We all know the statistical type 1 and type 2 fallacy, right? And then what you have done, the type 3 fallacy, when you actually conclude and say, oh, absolutely top science, but altogether the wrong problem, which very often happens. This is the problem starts really on the first formulation of what is the problem and whose problem is it and how are we going to frame it? What is the scope and the scale of the problem? So all of in these areas we very often, I think, come out wrong, particularly in the public. So we need this reflexivity also in the scientific community. Maybe the SAPEA report can have a certain educational function, maybe that part of the task as well. I don't know. I don't see. Yeah, I said yes. Come on. give him the microphone. Yes.
You said that the bureaucrats read everything, so apparently they must read this report also. And hopefully it leads to some actions. So my question is to all of you, because you, Øystein, described a system whereby we take whatever reports come from the European system and then we discuss them at home or translate some of it to the Norwegian scene. But we don't have a system whereby the government comes to the scientists, or have a system where they can do this systematically with their questions, or where scientists can come to the government with a big question that looms on the horizon. So how far are we away from a system similar to what they're thinking of in Finland?
I think we are quite far away from that, because there are so many science advice mechanisms functioning. They are partly institutional from research institutes or universities, or can be individual mechanisms. And on all these mechanisms, they have their history and they have their value and they have their protection mechanisms. And I think we really need, if I see this from the Academy of Science and Letters, we need to show first that we are able to do something which is obviously of use and is beneficial before we can start to claim that we now would like to organize or be co-organizers of a different, more grand science advice mechanism. Because that is in a way asking too much more than we are able to deliver. So that's why we thought that a good niche would be to exploit the international academy movement and say we are part of that, and the academies, they have a special advantage through their independence, and the individual members do not represent monetary or institutional interests as much as they do when they sit at home. So we can use the international academy movement's assessment work, SAPEA or ESAC in our case, and then we could see what can we extract from this and translate into a national context. So that has been in a way our goal, because that is something that is manageable. And then if that can add value to the Norwegian policy decision system in a way that is obvious to many, then perhaps that can then build on itself and become a more stringent mechanism with time. But I think we have to deliver something of value first.
We're coming to a wrap-up session. I would like to ask both of you then to come up with your wish list or what you take out of this. Ture, you want to start?
Yeah, and I'll just address the question you raised before I finish up, is that we have universities in Norway that are extremely well funded. There's a lot of scientists, and they should have this as their obligation to ask the right questions. I mean, that's why we have basic funding.
Wow.
That's why people have independent research. It's because they can ask the right questions. So I don't think there's any excuse for not asking the right questions in Norway. We are well funded. There's I don't know about any other countries with that high of a funding. We can afford it, and we should do it more than we do today. I think Norwegian scientists should ask the right questions more often than they do. So that's okay. And to wrap up, I think we have some mechanisms today that are really good. We have a public system that goes on and on about different inputs to political decision making, and scientists should partake in that, and they should know their craft, do it well, and understand the system and the process, and play into that process. And then we probably have some missing scientific advice that we've heard about today, that we can systemize, make more of those kinds of mechanisms. to supplement what we already have. But we should not forget what we already have, and I think we should, as scientists, partake more than we do today.
Okay, thank you very much. Torbjørn.
Well, obviously, in a small country like Norway, I meet colleagues from my 15 years in university management, and I go in the academies. I see many of the same faces that I used to see then. So obviously, we always we carry a backpack of history along. So. Maybe it's difficult to persuade the politicians that when we go through a certain door at Drammensveien or elsewhere, we all of a sudden we change our mindset to think completely differently. That may not be sellable in all contexts, and obviously the university people, as you challenge them, Kyrre. Their tradition is, of course, to argue for more research in their pet fields, and then to change that role and get credibility. If you say, now I'm doing something else, that is one of the real challenges. I think the academies, with the experience we get through working in the SAPEA and ISAC contexts, we learn a bit about how that role needs to be fulfilled. We learn about the traffic rules that we need to obey in order to get that credibility, so that I think we can, and whether you can go to the university and say you are obliged to do this and that, obviously you know enough about professors that you know that they cannot be commanded, not easily at least. And then so we need to find a mechanism to do that. And I agree with what Øystein says. If the academies can prove that we can fulfill that role in a credible way, we may have a case to base this independent science advice role in the academies. But I agree with you, we cannot go out there and say, now give us this and that, and we will roll this out on a large scale. That's not possible. We need to prove our trustworthiness and our capability to deliver on this.
I think that it's there is too much emphasis on individual excellence now in universities, and that the research topic is not as important as the number of publications and the age factor, and that and we have forgot about a very important role, which is to develop science should build the country in a general manner and not build the individual publication record to the same extent. And I think we have a lot to learn from the practice of, for instance, the national laboratories in the US and some other countries, how they actually evolved into very important societal building elements for long time periods. And they also created a number of Nobel Prize winners, but they didn't have the goal of individual academic freedom. They had a goal to develop something of common interest.
Yes, thank you very much. That bespeaks my favorite topic of the integrity in science. But that would be a topic for another meeting. And I think we can conclude this meeting. And I would first of all like to thank you, our panel. And secondly, you, the audience. I think you were a very good audience, and I hope that you can bring something home. And finally, I want to thank SAPEA actually for actually bringing us this report here to Norway. And as we have heard, this may start a lot of processes here in our country that we all may benefit from in building our country further. So thank you to all of you. Thank you. Bye-bye.